Okay, now we're going to start putting these equations of parabolas in standard form and graphing. So we have to put it in standard form so we can identify all the major features of the graph. So the first thing you should do is determine how the parabola opens. That will determine what form of the equation we should put this in. Because this is y squared, I know it's going to either open right or open left. Y squared means it's going to open side to side. X squared means it's going to open up and down. That's the one that we're familiar with. If it's an x squared, then it's a quadratic, which means it's a function and it's going to open up or down. If it's a y squared, then it's going to open side to side. Now to determine if it opens right or left, we're looking to see if the value of p is positive. And if your coefficient is positive, then you are going to have it open to the right. So I'm going to just make myself a note here that it's going to open to the right. And if it opens to the right, that means the form of the equation that we're going to put this in is going to be y minus k squared is equal to 4p times x minus h. So I need to get the y squared by itself, which means I'm going to multiply both sides of the equation by 8. So I'm going to get y squared is equal to 8x. Whatever's in front of the part that's not squared is going to be your 4p. So this tells me 4p is equal to 8, so p has to be equal to 2. And figuring out that p is 2 is key to graphing. Because this isn't shifted, my vertex is going to be at 0, 0. We know the value of p is equal to 2, so that's going to tell us where the directrix is and the focus point is. Okay, so here is the vertex. It's going to open to the right. So my focus is going to come out 2 from the vertex to the right. So this is going to be my vertex. This is going to be my focus point. My directrix is going to be the line that comes out 2 in the other direction of the vertex on the outside of the parabola. So my directrix is going to be the vertical line x equals -2. Now, to figure out how wide the parabola opens, it could open real skinny like this. It could open really wide like this. We don't know. So to figure that out, again, we're going to use our value of p. Recall that we have the diameter of the parabola, which is 4p. It come out a distance of 2p from the focus in either direction, and that will give us the length of the entire diameter. The diameter is the length or the line segment that goes from end to end from one side of the parabola to the other side of the parabola that passes directly through the focus. So I'm going to come out a distance of 2p from the focus in either direction to see how wide it opens. Since p is 2, 2p is going to be 4. So from the focus, I'm going to come out 4 units in either direction. So 1, 2, 3, 4, 1, 2, 3, 4. So now we know how wide it opens. So from here to here is 2p, and here to here is 2p. So the whole length of the latus rectum, or the diameter, is 4p. Now, if we want to check to make sure we got the points right on the parabola, let's say I want to check this point here. That is the point 2, 4. I can plug it into the equation and make sure it works. So if I plug in 2, 4, 2 for x and 4 for y, here's our equation. Y squared is equal to 8x. It should work if we did it right. So 4 is y, and x is 2. So I have 4 squared, which is 16. 8 times 2 is 16. 16 is equal to 16, so it works. And then by symmetry, you should also have this point on the graph as well, which is 2, -4. And if I plug into -4, that will work as well, because when I square and I put in -4 into the y squared, that's going to become a positive 16 anyways. Okay, next example, we have y plus 3 is equal to 1/4 x minus 2 squared. So notice what's being squared is the x. So this is going to either open up or down. Because my coefficient is positive, it's going to open up. So this is the form of the parabola that we're familiar with, the quadratic, where it's a function. I want to get the part that's squared by itself, so I'm going to multiply both sides by 4. That way we get it in this form, or its standard form. So if I multiply both sides by 4, I'm going to have x minus 2 squared is equal to 4 times y minus 3. Whatever is in front of the part that's not being squared is equivalent to my 4p. So 4p is equal to 4, which means p has got to be equal to 1. And this is key to graphing pretty much everything for the quadratic. Since it's been shifted, the vertex is going to be hk, which in this case is 2, 3. So when I plot my vertex at 2, 3, here's my vertex. I know it opens up, so I know my focus is going to come up 1, a distance of p, from the vertex. So here's my focus. And then my directrix is going to come 1 down outside the parabola from my vertex. So in this case, the directrix is going to be the horizontal line, y is equal to 2. Now to figure out how wide it opens, it comes out from the focus point a value of 2p. Since p is 1, I'm going to come out 1 times 2, a distance of 2p, so 2 in either direction from the focus, since it opens up, and it's going to look like this. Now, we can check to see if that point on there works. We have the point 0, 4, and we have the point in there 4, 4. We can check to see if we've got it right by plugging in those values into standard form and see if it works. So if I plug in the point 0, 4, that's going to be 0 minus 2 squared is equal to 4 times 4 minus 3. Negative 2 squared is a positive 4. And inside the parentheses here, 4 minus 3 is 1, and 1 times 4 is 4, so it works. And then you can do the same thing if you want to check the other point 4, 4 as well. Now in example 3, we're going to have to do a little bit more work to put this in standard form. The first thing you should notice is that what's being squared is the x. So that tells us that when we put this in standard form, we want it in this form. Where the x is being squared, and it's going to either open up or down, which is the parabola that we're familiar with, where it's also a function that we call a quadratic. So I'm going to have to complete the square for the x's and then put everything else on the other side and put it in this factored form here. So I want to get that 8y and negative 23 to the right-hand side. So I'm going to subtract both of those from each side. And I'm also going to leave a blank here because I'm going to complete the square. So I can write it as something squared. So I'm going to subtract 8y from both sides, and I'm going to add 23 to both sides. Now to complete the square, I'm going to take half of negative 2, which is negative 1, and square it. And negative 1, when I square it, is positive 1. But what I do to one side, I also have to do to the other side, so I'm going to add in a 1 on the right-hand side as well. So this is what I added in to both sides. Now I'm going to factor this. X squared minus 2x plus 1 can be factored as x minus 1 times x minus 1, which we can write as x minus 1 squared. And then on the right-hand side, we have negative 8y plus 24. Now we still have to factor the right-hand side so we can identify what our 4p would be. So I'm going to factor out the negative 8, and I'm left with a y minus 3. So now it's in standard form. Here's our standard form. So now we can identify what our value of p is. 4p is equal to what's in front of my parentheses. So that's going to be negative 8. So p is going to be negative 2. The fact that p is negative is going to tell me that this opens down. I know that it opens either up or down because what's being squared is the x, and then to narrow it down whether it's going to open up or open down is when we look to see what the coefficient is. Our value of p is negative 2, so that means it's going to open down. My vertex is my h and my k, so 1, 3. So here's my vertex. Since it opens down, I'm going to come 2 down to find my focus from the vertex. So there's my focus. My directrix is going to be on the outside of the parabola, a distance of 2 from the vertex. So my directrix is going to be the horizontal line, y equals 5. And now to figure out how wide it opens so that I can draw this, I'm going to come out a distance of 2p in either direction from the focus point. Since p is negative 2, I ignore, when we're talking about the distance, I'm going to ignore the negative. And I'm going to take 2 times 2 is 4. So I'm going to come out a distance of 4 from the focus in either direction. 1, 2, 3, 4. 1, 2, 3, 4. And then that will tell me how wide it opens. And then if we want to see if we've got the points right, we could plug in these 2 points here and check it in our equation. On this one here, again, we're going to have to complete the square. But notice what's being squared. It's the y that's being squared now. So this is going to open up either left or right. And once we put it in standard form, we're going to look at that coefficient that's in front of the parentheses, our value p, and determine whether it opens to the left or to the right. So anything that's not y needs to be moved to the other side, and we need to complete the square. So I have 2y squared minus 4y. And I'm going to subtract the 16x and add 14 to both sides. Now, in order to complete the square, I need to get rid of any coefficient that's in front of the y squared. We didn't have to do that in the previous example because the coefficient in front of the x squared in the previous example was 1. So first we have to factor out a 2. Okay, so I factored out a 2. Now I got to complete the square. I'm going to take half of negative 2, which is negative 1, and square it. That's going to give me a positive 1. But I didn't just add in a 1 because I have a 2 out here. I added in a 2 to both sides. So I'm going to add a 2 to the right-hand side as well so that I keep this equation balanced. So now I have y squared minus 2y plus 1 can be factored as y minus 1 times y minus 1, which we can write as y minus 1 squared. And then negative 16x, and then the 14 and the 2 gives me a 16. So I have a negative 16x and a plus 16 on the right-hand side. Now, I want to divide both sides by 2 so I can get the part that's squared by itself. So now I'm going to have y minus 1 squared is equal to negative 8x plus 8. I'm going to factor out from the right-hand side a negative 8, so I'm left with x minus 1. And now we have our standard form. My value of p is going to be negative 2, because if 4p is negative 8, then p would have to be negative 2, which means this is going to open to the left. We knew it was going to open either right or left because it was the y that was squared. The fact that p is negative tells me that it's going to open to the left. So the fact that y is squared and p is negative means it's going to open to the left. So now we have a vertex at 1, 1. Now be careful. It's coincidental that both the x and the y for the vertex is 1. However, because the y comes first on the left-hand side, doesn't mean that that's the one that goes here. We still have to keep it in the right order, that this x, this value here, comes first. The h always comes first when you're writing down the vertex. So my vertex is at 1, 1. We know it's going to open to the left. My value of p is 2, if I ignore the negative for a second, because when we deal with distance, we only deal with the positive. So since it opens to the left, my focus is going to be 2 to the left. And my directrix is going to be a vertical line now. Going to be the line x equals 3. So this is my vertex. I got my focus and I got my directrix. Now to see how wide it opens, from the focus out, I'm going to move out a distance of 2p. So I'm going to move out 4 in either direction. And that will tell me how wide it opens. And there's our parabola.